Hi everyone, my name is Eason. I'm a cloud solution architect from Microsoft Hong Kong. My role is helping customers to architect and design the cloud solution with our various Azure cloud technologies, including the application modernizations, data platform, and the data science platform as well. So today's I will try to introduce few topics in here. So the first topic, I will try to cover the introduction of the machine learning applications to try to introduce you what kind of applications can be built based on the machine learning and the AI technologies. The second topic, I will try to introduce the content surface, which is our candid pre-built API solutions. You can leverage it and then use to build your machine learning or AI applications. For example, sounds like speech recognition, knowledge understanding. We have lots of the great API. You can leverage it and then build your machine learning or AI embedded or infused application very rapidly. The third topic, I will try to introduce the content surface to Azure Machine Learning Studios. Although the content surface is great, can be covered most of the cases. In some cases, we are doing something advanced. We need to train our own model. I will try to introduce you, try to use our Azure Machine Learning Studio to train the sophisticated model by yourself. The fourth topic, I try to introduce some more advanced concept of the Azure Machine Learning Studios. Last topic, have a write-up, have a summary. Let's get started. So let's recap of the Azure Machine Learning or the machine learning applications. The machine learning applications can be cover various topics and areas. The predictive maintenance to try to see the historical trend of the problem of the errors with the cable errors. Okay, we can try to predict and do the maintenance proactively. The e-commerce recommendation engines very common nowadays. You try to click on some product you like and then recommend further product for use. Computer vision, very hot topic to try to recognize your face, recognize the objects, and so on. Forecasting the 9 numbers like the stock, like the performance, we can forecast the next numbers. Automatically driving agents, this is deep enforcement learning within the agents, within the environments. You can try to train your model to try to train the automatically driving engines or deep learning models. Language understandings, understand what you're saying, and then capture the intent and do the right thing for you. So today I will try to focus on one of the very common topics in the machine learning and the deep learning spaces, language understandings. To understand your language, this is very common and very hot topic. For the ambient computing, you give orders to try to execute a command. Obviously, we need to understand your language, understand what you're saying to capture your intent. And language understanding is not just capture voice and then doing some action for you, right? So we can leverage the understanding model to try to do the automations, obviously, and the solution scale. And with the understanding of the languages, with the long papers, we can unlock the unstructured data from the long sentences, long paragraph, understand the books, understand the paragraph, and then capture the meanings inside your paragraph. It's also empowered by the language understanding models. So let me do some demo and tell the story about the Tailwind Traders. Tailwind Trader is the largest tools and utilities company store to try to sell their hammer, sell their saw, sell everything else, okay, sell the tools. And then they have an e-commerce platform for their product selling. So the story is about the pre-built model to capture the task analytics if someone leaves the comment, this hammer is very good to use to try to use our pre-built model to do the basic and first step to do the analyze the text. Is it good? Is it positive or negative? And then at the last step, we will try to customize our model with the very sophisticated with our own data to train our model to improve the accuracy with our own data, with our own knowledge. So let's do the demo of the text analytics. So as you can see the screen, this is our text analytics API portal. You can just very easily to access. Maybe you can try to bring quantitative surface text analytics. In the text analytics website, we already build the developers or even user to very easier to understand to realize the power of the text analytics. So let me try to type in something in the text box in here. You can see and then realize the analytic result lively from the website. Let me just type I love a polka dot plant abroad in London store. It will capture the key phrases. The dot patch and London store, obviously, this is the key phrases we can capture from the sentence and capture the statements of your sentence in here. This is positive. Let me try another sample. Okay, just one wording. Let me try to copy and paste. That's very interesting situation in here. Love and hate. In the sentences, I tried to say I love the polka dot pants, but I didn't like the London store and farmers. That's a very interesting situation when we're saying the text analytics, because this is overall scoring of our entire sentences. And you can see the positive and the negative is really in the middle. You can see the positive rate is 15.6%, and the negative rate is 42%. It's hard to capture to see this comment of the result. Is this really good comment or negative comments? That's very interesting situations. So that's why we need to try to train some more advanced model, okay, to serve for various or very sophisticated purpose. This is an example to try to say the food is very fresh and very attractive. Obviously, this is a very positive. The sentiment is very good in here. The confidence level is 100% in language, in English. The sentiment is 80% is very good sentiments. So why we use the Azure Quantitative Service first? Because it is easy and fast. Because without the data science or very sophisticated machine learning or deep learning knowledge, you can, even a normal user, to build a very leverage our API easy to use to build your machine learning or data science or deep learning and power infused applications. So very easy to use, just call the API. You can just pass the text phrases to the API, and then you can gain the results. Is it positive, negative, what with the key phrase of the sentences, just the result, just use it. So it's very easy to use. It's flexible. It's available to most of the common platform nowadays. Obviously you can use Windows, Android, iOS. You can use the languages like the Node.js, Python, Java, C++, C#. We have a lot of SDK to fulfill your requirements depending on preferred languages. And this is the tested. We have a lot of experience on the researching from the brain, from the Azure Machine Learning, all the experts. We have the great communities in the GitHub, in the Stack Overflow, in the user voice and SDN to try to support for you. So if you would like to learn and understand more what is the full capabilities of the text analytics API, you can try to check out these articles. So this is the first step. You can see, even I haven't very deep knowledge of the machine learning or data science, I can leverage the pre-built and candid cognitive surface, which is text analytics, to build my AI or machine learning or deep learning infused applications. It can be very fast, but back to the programming's 18-20 rules. 18% of the cases we can cover by the pre-built cognitive service. But in some cases, let's say 20%, we also need to build by our own. We need some knowledge to fulfill some of the very sophisticated or very special requirements. So what is the Azure Machine Learning service? Actually, Azure Machine Learning service is the data science and the machine learning platform. It included lots of the service because when we say Azure Machine Learning saying is a data science and machine learning platform, is required compute, required data source. It is collections, a single pane of glass for the data scientists or data engineers, data analysts. Within this Azure Machine Learning service workspace, you can build your machine learning model, a deep learning model, or even reinforcement models. It supports the Python SDK, the R, all the common languages from the data science space. It also enables you to prepare the data within the workspace because we are saying we are building a platform, okay? Within this platform, we are also able to allow you to prepare the data, build the models, train the models. Some of the key topics I would like to share in another sections, how to manage the models, because we are just trying to train the model and save the laptop is not a great idea because you cannot see the model performance, model difference. You can track the performance. You can leverage the Azure Machine Learning platform to manage your model for the deployment. You can track your experience every time you try to train a model. You try to tune your hyperparameters to see the model trainings, performance gain, or being dropped. And you can also leverage the Azure Machine Learning Studio service to try to deploy the models to the partner service. Just like a container instance, you can use the Azure Machine Learning service to train your model and the package as a containers, and then use the very minimal Azure container instance to serve your model, maybe API, maybe a website. You can also deploy the model in the AKS in larger scale. So in the workspace, Azure Machine Learning is a lot of the key features in here. Okay, so with the models, as I said, you can track the model and then save in a single pane. You can manage the experience in a single pane. The training, you can keep training your model and then track your experience in the Azure Machine Learning Studio workspace in here. You can track the pipeline to do the further integration with the DevOps. You can select the compute target, how many compute you want to train the model, just in case you have doing some very sophisticated deep learning model that require the GPU target. In the Azure Machine Learning workspace, you can create the training compute to define how many nodes you can try to train your model in here in a single pane. This is also supported not just structural data, is also supported unstructured data in case you would like to try to train some computer vision model. Maybe you have some images data. Definitely you can import to the workspace for the model training purpose. For the deployment, you can leverage the Azure Machine Learning service to deploy your model after trainings to the productions with the integration with Azure DevOps or other DevOps tools to get your latest trained model and then do the automatically deployment to the productions, to the UAT, SIT, and then after the testing, you can do the productions. That's the deployment and control and management you can achieve in the Azure Machine Learning service as well. It has a data store. You can leverage the Azure Machine Learning service to connect various data stores in Azure. So building the baseline with the AutoML. So I will going through a demo how to use a first step, very easy to use using our Azure Machine Learning services to build a model without any knowledge of the data science and machine learning because we have a AutoML features. You just need to prepare the data, define the goals, apply the constraint, what kind of constraint you can define. Let's say some of the rules, some of the column, okay, some of the data, you need to filter it out, define your goal, what kind of column with the result data set, and then definitely you need to prepare the data. And the AutoML features will be automatically test all the algorithm and then find the best model for the deployment. Let's say after trainings, we could test 100 of different algorithms and then see the model performance and then see the latest model and then do the further enhancement of the model and then do the optimizations for the deployments. Let's go for a demo. In here, this is my Azure Machine Learning Studio workspace in here. You call it workspace or you can call it surface. First up, as I said, the Azure Machine Learning service can be ingest lot of data to the workspace for the training purposes because you can just use the dataset to try to ingest your data, create dataset, and then import in here. And obviously, you can do some integrations to grab other data source within Azure or with outside of Azure. Let's click to the data store in here. In here, I already prepared a data source from the Azure SQL database. In my example of the automatically trainings, my dataset is saved in the Azure SQL database, and then I will try to leverage that kind of dataset to train my model by automatically ML. Let's try to, for illustrations, try to click on the data store. You need to define the name, maybe testing. Select your data store type, like maybe your images data saved in the block storage or file share storage, or even you save the data in the data lake store, or you are saving into the relational database, SQL, Postgres, MySQL database in here. And then if you are using Azure, you can select your subscription, select the right name, select the right container, that's mean the folders, authentication type, and then make it a data source, data feed of your model trainings. So in here, let's start from the beginning. So click on the AutoML, click on the automatically ML run in here. First up, you need to import your dataset. This time, I have a comment, okay, of the scoring of the data. I will leverage that data, the settlement score, and then use that to train my own models. Let's see my data first. Goes in ML. Dataset already import to the dataset workspace of the Azure Machine Learning. In here, you can export the data. You can see just two simple columns inside this dataset. This is a comment from the user. I'm happy to use a so pretty of the tools, maybe the hammers, and then the rating of the comments from the system. It's 5, the max. Maybe it's just 1. This is obviously this is a negative comment in here. You can see. So let's build based on this dataset to try to train my own model. Click on New Automatically ML1 for illustrations. Although you can see the dataset already here, let me try to import the data. You can import from the local files. Maybe you have a CSV file, Excel file. You can also import to the workspace, access workspace, or you can collect the data from the data source directly. In here, I can collect to the data source. As I said, I already collect to my SQL database in here. Select the query, find your right table for importing purpose. and then you can import the data source to the data set, and then do the next step. So I already imported, so that's why I just click, and this is the tabular. This is tabular data, the structurals. Let's click next. Scenario experience lamp. You need to create it, okay, if you don't have it. So create a sample, maybe in my cases, it's calling closing settlements. If you don't have it, just create a new experience. And then every time you try to retrain the model, all the performance, all the matrices will be saved in the same experience. Try to track the model training performance. So because as I show you the data, the explored data, we just have two columns. So we need to see the results. The result is obviously its rating. This is our result column. With the digestion of the text command, we build the task, and then with the matching of the rating, and then train the model, my result will be illustrated as rating. When I try to type something new taxes, it try to predict the corresponding rating for me. Then you need a compute to try to train your models. So in here, I already pre-built and pre-created two cluster in here. I call it AI/ML 14 train. Or if you don't have it, obviously you can very easily to create compute. You don't need to ask your infrastructure guy to try to create a compute for you because it is centralized, it's managed inside the Azure Machine Learning service in here. Just type a simple lamp. Let me test one for illustration purpose in here. Type your machine purpose. Depends on the requirements. You can select how many CPU cores. Okay, so many different various combination in here. Or in very sophisticated model, you can use the NC series. That means the GPU model to expedite, to speed up the model trainings. In here, we have two options, which is dedicated and low priorities. Low priority is a spot instance. It will leverage the idle compute volume. Obviously, the pricing is lower. Depends on it. You will need to have a guarantee. Obviously, you need to select a dedicated virtual machine priorities in here. You are required to select the minimal number of nodes. From here, the default value is 0, because after training, it will be idle, right? It's not necessarily 20 on 24/7. You can set the value to 0 in here. Just in case the normal model is running, the cluster will downscale, will scale in to the 0 at maximum. The model will be, the training cluster will be automatically scaled up to the 6th node of the D12 V2 machine. If we talk about the D12 V2 machine, it is about 4 gig virtual CPU and 20 gig memory. It's large already. So the idle timeout for the scale down after the 120-second idle, if no more training is coming on, it will automatically scaling down. Okay, I need not to create new compute here, just using my existing compute for the trainings. Let's kickstart for next. So in here, there are various tasks you can select. So in here, we are doing some classifications model because we want to classify the tax settlement is what. Obviously, this is a very traditional classification model in here. So that's why I will select. And you can see automatically detect the classification model as well. And obviously, you can do some regressions, depends on the data. Maybe you have a time series data to predict the next value, maybe the stock market, maybe the maintenance data. You can try to predict something. You can select the regression or time series forecasting, and then you can click finish. And then the model will be automatically run. As a preparations, already trained the model in here. There's already trained one time already. You can see the accuracy is already up to the 97% already. And then view the model result. You can see the algorithm names being selected after the round of training and the tunings. You can up to the 97%. You stack example in here. This is the best algorithm. Okay, we are automatically selected to serve for this run. So you can see all the if you have a data science learnings, okay, you can see all the graph, the ROC core, the precision recall, all the graphics, confusion matrix. You can see all the graphics to try to see why this is the best model being picked for the deployments. So in here, you can deploy the best model in here automatically, or you can download the best model and then you can deploy it by yourself. Obviously, this is not recommended. Let's see the endpoint. Sorry, I excluded the model first. After the model has been prepared, you can deploy your model in the endpoints, the real-time endpoint within the Azure Machine Learning workspace. So back to the slide. So we can so easily to leverage the auto ML features with the prepared data, well-prepared data, and then the Azure Machine Learning will be automatically select the right algorithm and then train the model for you. And then based on the accuracy rate, and then you can select the right algorithm models and then for the deployments. We have official document articles. You can just refer to the official article to try to follow through simple stuff, and then you can build your automatically model by yourself. Very simple. So let's do some advanced Azure Machine Learning service in here. In here, okay, you can see, as you can see from the very beginning of the demo, you can see the detections of the taxes is not by each word in here. It sounds like it seems to be by average of the sentences and then get the averages of the settlement in here. Actually, we can do some more sophisticated and advanced NLP model with the NLP architect, which is introduced by Intel AI, to try to do the aspect-based sentiment analysis. With the full sentences, you can see from the illustration here, we can capture corresponding sentences, okay, entirely, this is a whole sentences. You can try to capture each of the wording, the statements. And then you can fully understand and then compare the each of percentage. So Azure Machine Learning is the end-to-end process. It's end-to-end solutions for the data science and machine learning workspace. It's served for multiple users. Maybe it's just a normal data engineers, data user, you can use it. Maybe you haven't the deep knowledge of the machine learning. You can also use the automatically machine learning features. It also support end-to-end process of the machine learning as well. From the prepared data, ingest the data, as you can see from the previous demo, to try to train your model. You can also achieve in the Azure Machine Learning Studios. You can use your preferred language and the tools like Jupyter Notebook and the code. Train the model and then register the model, try to track the performance. After the training, you can register the model for the centralized management. Build the images as a container for the deployment purpose. And you can also leverage the Azure Machine Learning workspace to deploy the model to Azure Container Instance, Container Surface. So let me try to focus on the experience and try to build your model from the favorite IDE and train the model and then register the models. So for the Tailwind Traders machine learning challenges they have failed, they would like to have an environmental dependency because they use a lot of the libraries. Obviously, we need to have a platform to able to inject, import all the necessary library for the model trainings. We are also allowed the cross-team cooperations because they are not just one team for the model trainings. We need to prepare the data. Okay, we need to manage the compute as well. We need a platform for easily to manage the data injections and the compute as well. We need to meet with the compliance and interoperabilities for the control and governance purpose. We also require the distributed trainings. So, what is the challenges of the distributed trainings? Distributed trainings, we need to schedule a job, distribute the data, scale the result, provision the VM, gather the results. Obviously, we need to manage the assets, and sometimes we need to manage the failures. So in Azure Machine Learning Studios workspace, this is a managed service. You need not to manage the infrastructures. You can just use and train the compute. Let's go for the demos. So back to the notebook. In the first demo, I will use the notebook compute to try to illustrate or to show you how to use the notebook compute to train the model with the cooperation with the Azure Machine Learning service in here. So the first step, okay, if you are using the local Jupyter Notebook, it's also fine. If you're not using the Azure Machine Learning Studio, it's provided over the box notebook service. You can use the notebook service in here to try to run your Jupyter Notebook, or you're using local machine. You can also import the library. Then make sure your training post mathematics and the model registration able to register and cooperate with the Azure Machine Learning workspace. First thing first, import the libraries with the Azure Machine Learning Studio SDK. Let's have the definitions to create the experience, define the model, define the after the trainings, deploy to what kind of Azure container instance, and also define the cluster as well for my model trainings. So the first step is, okay, I will initialize my workspace, okay? I need to connect to my workspace first. After the connect to the workspace, I need to attach to the compute cluster for the trainings. So in here, I will try to create a new compute cluster based on the D3 V2 compute. If the compute is not exist, compute cluster is not exist. This is a minimal cluster from 0 at minimal and maximum 4 nodes to try to train my models. I need to connect to my data store to grab my data for the model training purpose. In next lab, okay, I will try to create an experience for the trainings. SIP defined in the constraint in here, it is called the ABSA. Create the experience. The next step, all is prepared, and then based on my coding, and then I can trigger the want and run based on the Azure Machine Learning Service workspace. Submit the want, and then you can see the command in here to try to capture the result. And the result is not just able to see from the Jupyter Notebook lively in here, or you can go into the experience. You can track the performance, matrices. You can track the performance one by one of each one. After the training has been completed, we need to register the model back to the model workspace in the Azure Machine Learning Studios. Just like you can see in here, the model is being registered. Have a task of the model to try to see the accuracy, to try to use my sample data set to try to test the model accuracy. And then finally, we can see the result in here. You can see this is my sample sentence in here. And then capture each of the wordings. Is this the positive or negative? If you like the models, definitely next step is try to deploy the model in Azure. So know the latest budget study model, okay, from the model workspace of the Azure Machine Learning. Create environments. This is a very important step. Try to import your machine learning model. You just create it and then create environments. Create the interference configurations. That means how to make your model expose and interact with the API. After this has been done, we can deploy it to the Azure Container Instance. As you can see, you are not necessary to going out to outside of the Azure Machine Learning Studio in here. You can just using the single plane, single workspace to deploy the Azure Container Instance as well. After wait for a while, you can see the model has been deployed, just like you can see it's a set in here, and then get the scoring result by testing after the deployments. So back to the slide deck, okay. You can see this is so sophisticated and complex process. You can try to refer to our official documentation article to see all the references and sample in here as well. The Azure Machine Learning workspace is also supported the hyperparameter distributed tunings. So what's first step is what is hyperparameters? Just like a switch, okay, but we have a lot of switch. We try to tune, to find the fine tune, to try to get a better accuracy of your models. This is a traditional manual approach for the hyperparameter tunings. This is an iteration process. You try to have a hyperparameter tuning configuration 1, 2, 3, 4. Maybe you keep trying it and see the performance and track the result from your experience. And then you can see after the model config run, you try to train the model 1, and then you can try to evaluate result from the experience to see the model accuracy rate, is it going high or going low or not. And then keep trying lots of the combination of hyperparameters to try to train the model again, model 2, or even model 3, and try to switch the algorithm 1, 2, 3. Maybe you try to tune the hyperparameter again to 4. This is a completely complex and tedious and repeating process. Obviously, this is time consuming, and as consequence, this is an expensive process because you are using a lot of computers to try to keep training your models. So the automated hyperparameter tuning is one great feature offered from the Azure Machine Learning service in here. It's automatically based on your predefined policy. To try to base on the policy you have defined it, and then keep searching, keep tuning the hyperparameters with various combinations of the algorithm parameters, and then you can gain the result and then see the result which one is the best tuning of the hyperparameters, and then do the further deployments. Let's go to the demos. So back to here. This is the notebook workspace. I already connect to the Azure Machine Learning Studio workspace in here. Just like the demonstration before, I need to import the necessary Azure ML libraries. Connect to corresponding environment I have created. If not created, you can obviously just very simple to create it. Fine-tune the model with the Azure ML hyperdrive. The automatically train hyperparameter tuning is called hyperdrive. You need to define the parameters, need to be tuned in here. Set the termination policy, define the rules, it will stop it. create estimators, and then create the hyperdrive configurations. The next step, run the hyperdrive configurations, and then you can monitor the hyperdrive one. In here, you can use the UI tools to try to see the hyperdrive training performance. 16 has been completed. You can see the F1 weight in various combinations of hyperparameters has been run. And then you can show the result from the notebook as well. And obviously, you can very easily to find the best model in this time. I will base on the F1 score, 91%. Best one is number 7. Wow, you can see I have run automatically 14 run in here. The run 7 is a perfectly candidate. It's automatically. It's without any interactions. This F1 score is higher. And then I can base on this run and then deploy the models. So for official documentations, you can refer to here. Some of the sample you can follow. Some of the parameters you can follow from the document as well. Let's have a recap of how Azure Machine Learning works. This is an end-to-end machine learning process. You try to send the experience, try to track the process. Number 2, create. Wait a second, sorry. Need to be lagging. Yep, back to here. Take the snapshot to send the experience, okay? And then we create the Docker images for you. In the Docker images, we can register it and then deploy the model. So in the review, we have reviewed the industry advance of the AI applications. We have introduced the text analytics 18 entity rules. 80% of the application we can use the pre-built candid machine learning API to try to build a AI-infused applications. 80% you can fulfill. Maybe 20% you can train your own model to fulfill the sophisticated requirements. You can build a customized machine learning model by Azure Machine Learning Auto ML. You also use the trained real-world AI model with the NLP architect within the Azure Machine Learning Studio. You can see, and then you can also see the try out the training model as well. Some the documentation alerts. Again, in here, you can refer to official documentations to try to use the MNIST, very common, the classic sample, and the scikit-learn, okay, to try to build a image classification model within the Azure Machine Learning service. Some more materials I try to consolidate in here. And we also have a MS Learn portal to guide for you to have an entry of the Azure Machine Learning as well. And after you take a lot of experience and testing, you can consider take a certifications. We have data scientist and data engineer associate. And all the lab resources, all the materials you can obtain from here. Thanks for your time to join these sections. Hope this is helpful to give you more understanding how to use our Azure Machine Learning Studio service to try to train a sophisticated and fast model. And you have some more understanding how to use the 1820 rules to try to leverage the candid build API service with the AI infused it to deploy your AI infused applications very rapidly. And you can use the Azure Machine Learning service to try to train the remaining 20% of service to build your sophisticated machine learning or AI models. Hope this helpful. Thanks for your time for joining.